Hi and welcome to the Data Platform Virtual Summit 2022 and to this presentation, Association Rules Step by Step. My name is Dejan Sarka. I am a freelancer consultant. I have more than 35 years of experience with working with data science, relational databases, SQL Server, languages like R, Python and more. I authored and co-authored 19 books so far and also many courses, articles, presentations. In this presentation, I will develop association rules model step by step in Transact SQL, and then I will also show you solutions in R, in Python, even with good old SQL Server analysis services multidimensional, and Azure Machine Learning. Let me start with a short introduction to the theory behind. Association rules is used for market basket analysis and is a typical undirected algorithm. There is no target variable, we are just searching for patterns and rules in our data. We have transactions and we have some products on these transactions. Association rules algorithm considers each attribute value pair, such as product bicycle, as an item. So any specific product is an item. An item set is a combination of 1, 2, 3 or more items that were purchased in a single transaction. Typically, we have orders and then order line items. And the algorithm basically scans through the dataset, trying to find item sets that tend to appear together in many transactions. However, let me point out that although this sounds extremely simple, it can become easily very complicated. The main complication is that we can get, even with only a couple of thousands of products, millions of possible combinations, and it's kind of hard to find out which ones are really important. Therefore, we can also check the importance of the rules by checking negative associations, which products have negative impact on sales of other products. So let me start defining the possible calculations for the association rules algorithm. The first thing that we calculate is the support. This is the number of rows with the item set compared to the total number of rows. So we can express this as a proportion or as an absolute number. For example, here I have 5 transactions. Transaction 1 is frozen pizza, cola, milk. Transaction 2, milk, potato chips, and so on. The support for the rule, if customers purchase cola, then they will purchase frozen pizza, is 0.4. There are 5 total rows or total transactions, and 2 of them include both cola and frozen pizza. Calculating support basically means calculating counts of item sets. Let me start with demos. So I will switch to Transact SQL. I will use the AdventureWorks demo database, AdventureWorks DW 2017 in this case. Here we have 2 views, the ASOC-SEC line items and the ASOC-SEC orders, but I will create permanent tables out of them for better performance. And I will insert all of the data for line items in a table and add a primary clustered key. And then I will create a permanent table out of orders and add primary key also to this table. Let me show you what is inside these tables, and also this way I am warming the cache. So I have order number, which defines transaction, line number, and we have model. So in order SO61313 we have 3 models: route 350W, cycling cap, and sport 100. Orders are not really needed for basic association rules, But here I have also with every single order associated customer key, customer demographic data. I added region and income group to every single row in the ASOC orders table. So I can also do some additional analysis over these additional columns. Now I can start with frequency of item sets with a single model. This simply means counting how many times a model appears in all transactions. So the most popular model is Sport 100. Second most popular model is water bottle. Of course, you can see that we have bikes and other sport equipment. This AdventureWorks demo database is about AdventureWorks fictitious company that is selling sport products, especially bikes. Now let me try to find negative products. I will start by analyzing which models have we purchased only once and in a single order, and nothing else was in this order. So customers just bought this model and never anything else, never returned to the store and never bought any additional model or product together with this one that I'm searching. So I am counting distinct order numbers and distinct models, and I am filtering those where I have count of distinct order number and count of distinct model equal to 1, both of them. So I have a product or a model that was purchased only one in a single order. And let's see how many times this appeared grouped by the model. So water bottle is somehow very negative product. It is the first product in the list of products that were purchased only once and nothing else was added in the basket, and the customer also didn't return to the store. However, if you remember, water bottle was also very popular model. Immediately you see it's not so easy to decide is this a positive or a negative product. Also think about real life. Maybe a customer just went for a biking adventure and forgot the water bottle. So customer just jumped to the closest store, purchased water bottle, and there was no need to purchase anything else. Maybe the second product in this list, women's mountain shorts, is more negative because it was not so popular. You already get the feeling that we need to look at this data from many different angles, from many different perspectives. Now I can use these additional columns in the orders table. For example, I can pivot these negative products over the region and see in which region which products are more negative. So, for example, water bottle is especially negative in region NAM. This is North America. Not so negative in Europe and probably not at all negative in the Pacific region. Of course, I could also analyze this as relative numbers, but I will not lose too much time here. Let me just also do the same pivoting of negative products by income group. And let's see how it works in different income groups. And I can see that distribution of negative purchase of water bottle is quite equal in different income groups. We cannot see immediately some very important pattern here. Maybe if we look at the second product, women's mountain shorts, then with low income group, the number of these purchases where this was the only model in a transaction is quite low. So we are learning something step by step. But let's now count support or frequency of items with two models. So what do I need to do? I need to join table, this line items table, to itself, based on equality of order number and model from one side is greater than model from another side. and then I will group by this combination, T1 model, T2 model, and calculate the count as support and order by support descending. So here we have the most popular combination, water bottle, mountain bottle cage with support 993. Also the second most popular item set is water bottle, road bottle cage. So you see water bottle is after all quite positive product. The third one, Sport 100, was not a negative product and it's also very popular in combinations. So this is probably even more positive product. Now I will express the same query differently. Instead of a join, I will simply use cross apply and in a tabular expression read from the same line items table again, joining by order number and searching for pairs where model from one side is different from the model from another side. This is completely equivalent query. I kind of prefer this one with cross apply because it's somehow easier to follow when I further develop my queries. You will see immediately what I mean. Now I will add a third model to the item set, so I will check frequency of item sets with 3 models. So first I will calculate all possible pairs by using cross apply operator, and then I will add with another cross apply the third product and I will find all triples, and then I will group by all 3 models in an item set and again order by support descending. So let's see which are the most popular item sets with 3 models. So it's mountain bottle cage, mountain 200 and water bottle. This combination appeared 343 times. Mountain bottle cage, Sport 100, water bottle 281 times. Okay, we already learned quite a few things. But I was talking about association rules, not only about item sets. And so far we analyzed item sets only. So let me quickly switch to slides and introduce the next measure, which is called confidence. Now I want to express pairs of items as a rule. If condition, then consequence. So for example, with combination milk and potato chips, I can get 2 rules. If customers purchase milk, then they will purchase potato chips. Or if customers purchase potato chips, then they will purchase milk. Of course, the question is which rule is better. Let me switch quickly to the previous slide and see this item set milk and potato chips. It actually appears only once in transaction 2. However, milk appears in transaction 1, transaction 2 and transaction 4. On the other side, potato chips appears only in transaction 2. So whenever potato chips is in the basket, milk is also in the basket. However, when milk is in the basket, only 1 out of 3 times potato chips is also in the basket. So let me now define the next measure and call it confidence. The confidence of an association rule, please note that now I'm talking about rules, not item sets. This is the support for the combination divided by the support for the condition. So the support for the combination potato chips and milk is 20%, 1 out of 5 transactions, and the support for milk is 60%, 3 of 5 transactions, and the support for potato chips is 20% or 0.2. Confidence for the rule if milk then potato chips is 0.33, 20 divided by 60. And confidence for the rule if potato chips then milk is 100%, or probability is 1, because whenever there was potato chips in the basket, there was also milk in the basket. So let's calculate also the confidence and switch back to the code. So first I will need all possible pairs of models, even when the same two models appear in a pair, just first time one model A, let's say, on the left and model B on the right, and then vice versa, model B on the left and model A on the right. So I'm having the same query as I had earlier, only in this tabular expression in the cross apply part, I changed the where condition. So I'm still joining our order number, but here the condition is that model from the left is different from model from the right, not greater or lower, but different. So I will get all possible pairs. And ordered by support descending, I see the first pair is water bottle, mountain bottle cage, and the second with the same support, mountain bottle cage, water bottle. Now I need to calculate the confidence. I express rules with this arrow sign, and support we already know how to calculate, but for confidence I need support for the condition or count how many times each model appears. So I'm having this in another common table expression. And also to calculate the relative numbers, I need the total count. So I'm counting how many transactions there are, count distinct order number. I'm getting a single result, 13,006 orders. And I'm getting a single row, and I'm adding this column with a cross join to all other rows. Then I can calculate support as percentage and then also calculate the confidence. So let me now execute this query, and I see first pair, mountain bottle cage, water bottle. If I express this item set as a rule where on the left side in the if is mountain bottle cage, as a consequence is water bottle, I have support percentage 7.63 and confidence 83%. If I turn the rule around, water bottle then mountain bottle cage, the support is still the same, but confidence is less than half of the previous confidence, so it's less than 40%. So apparently the first rule is better, mountain bottle cage than water bottle. So this was the confidence. Let me switch back to slides and add another measure, which I will call lift. This is also called the interesting score, sometimes also called importance of an item set. Lift of an item set, please note that I'm talking now about item sets again, not about rules, is probability for the combination divided by the multiplication of probabilities for every separate item in this item set. If importance equals 1, then A and B are independent items. So joint probability is practically equal to multiplication of individual probabilities. If importance is greater than 1, A and B are positively correlated. If A is in basket, there will be more B in the basket, and vice versa. If B is in basket, then there will be more A in the basket. If importance is lower than 1, then A and B are negatively correlated. So with lift, we will also get negative associations. Let's switch back to the code and try to calculate also the lift. So again, first time in the first common table expression, I am calculating all possible pairs. Then I am expressing these combinations of items as rules, calculating the support for the condition or count distinct of every specific model. And then in the final query, I am, besides support and confidence, also adding the lift, which can be again calculated through probabilities by using the total number of orders, which I get with a cross join to each row. and then I can calculate lift as support, relative support for the combination, divided by multiplication of probabilities of every single model in this item set. So let's execute this query, order it by lift descending, then confidence descending. We can try with different ordering very soon. And here we see the biggest lift is in this pair touring tire tube. And then we have road 250 HL road tire. Also this combination has very high lift. But confidence, let's go back to the first pair. Confidence touring tire then touring tire tube is again much higher than confidence touring tire tube then touring tire. If I go to the end, I get very low lifts as well. So these lifts that are lower than 1 means actually those lifts mean actually negative correlation. So if there is ML road tire in the basket, there is less chance that there will be also long sleeve logo jersey in the basket. Let me now execute the same query. Just this time let's order by support descending and then confidence descending, and see how the results look now. Of course, now in the first place we have this combination mountain bottle cage water bottle with the highest support. Lift is also quite good. So altogether I would say this rule, if mountain bottle cage then water bottle, is a very good rule. We have very high support, very high confidence, and also quite high lift. Altogether we came to some conclusions. We can find the best possible rules. I have nearly exhausted possible calculations for association rules. There is one more term I can introduce, and this is the order. You can have order in line items. For example, in internet sales, you know the order of products in the basket. Of course, in the retail sales, typically in big supermarket, this order is completely mixed when you come to the cashier, so you cannot count on it. But if you have this order, then you can create sequential association rules. Order can be defined with a sequential number like line number or maybe with date and time. Finally, you can also add two virtual products, let's call them begin and end. Add these two virtual products to every single transaction or every single order. This way, we can easily see which products come to the basket first, right after begin, and which products finish the shopping sequence. These are the products that are right before this fictitious product end. So let's go back to the code. Now I have data from internet sales. This is the scenario for this Adventure Works DW orders and line items. They are from internet sales. So what do I need to do to add the sequence? There is only one little thing I have to do. I have to change the condition in the where clause of the tabular expression in the cross apply clause. So besides order number from the left equals order number from the right, and model from the left is different from the model from the right, I have also to add additional condition that line number from the left is lower than line number from the right, and I have the sequence. The rest of this big query is the same as it was when I calculated the lift. Now I have this order mountain tire tube, then sport 100. This is now the combination in this order with the highest support, 747 cases. Now let me add begin and end. I know that the lowest line number is 1. Let's see what is the highest or maximal line number. It is 8. And we already know we have 13,006 orders. and altogether we have 32,166 line items. So let's insert in every order a product with line item 0 and name begin, and a product or a model with line number 9 and name end. So this is double the number of orders, and let's see what I get now in my line items. So for example, here I have order number SO61313. I have now 5 products, model begin, then road 350W, cycling cap, sport 100, and finally with line number 9 I have the model called end. Now let's calculate sequential rules together with these two new fictitious models begin and end. Of course, I see the most popular combination now is begin and then end, which appears of course in every single order. But I can also see that Sport 100 is many times the product that is finishing the sequence of shopping. We have confidence of 100%. Of course, Sport 100 appears the same number of times, 3,782 times with begin, so support is still the same. We know that Sport 100 is the most popular product, but confidence is much lower here. So apparently Sport 100 is typically the product that finishes the shopping or buying sequence. So you probably don't want to offer it immediately when a customer comes and begins a shopping sequence. Now we really know a lot about these rules. So the next thing is to show how to calculate these rules in different languages. I will start with R. And here we are in R Studio. I will use library A rules. I already installed this package, so I'm just loading it in memory. And through library ROWC, I will connect to MySQL server and read data from my ASOT line items. So all I need is order number and the model. So I can even remove the connection and let me view my data frame. So again, I see my orders, order number SO61313. I have model cycling cap, road 350W and sport 100. I can also save this data frame to a CSV file, and I will import this in my Azure Machine Learning service. Now I will define transactions, so I will split them by order number. This is the information about transactions. We have 13,006 transactions and maximally 37 items in a transaction. So this is now a sparse matrix with 13,000 rows and 37 columns. Let's inspect some transactions, for example, transactions with numbers or rows from 6 to 8. So I see I have transaction ID, which is order number, and a set of models. Let's see the size of this set. The set with sequential number 6 has size 2, and 7 and 8, they have size 3. I will use function a priori to define or calculate the association rules. I will feed this function with transactions, and I am searching for rules with minimal length 2, support at least 0.03, and confidence at least 0.05. And I'm targeting rules, not item sets. So let's calculate the rules, and let's use the function inspect to see these rules. Let's enlarge this window and see first rules. So I have ML mountain tire tube, and of course the other rule again, mountain tire tube, then ML mountain tire, and I have support, and later I have also confidence, and I have lift, and also the count. So I have all of the results I got in Transact SQL. So let's calculate support for most frequent items with again this maximum length of item set of 3 and minimal support 0.03. So these are these item sets, and let's inspect them, and I can see what I kind of already know, that these are a set of 40 most frequent items, not sorted by support, but these are well-known items from previous queries and R functions. So let's plot the top 10 items with item frequency plot function, and again I got the same result as in Transact SQL. Of course, the most frequent item is Sport 100, then water bottle, then patch kit, and so on. Now I will sort rules by confidence, decreasing also equals true, so it will be confidence descending. And let's inspect first 6 rules with the head function. So we have the highest confidence is in the rule if road bottle cage, then water bottle, confidence 0.89. Touring tire tube, confidence 0.87. I can also see support, and remember this combination, second one, touring tire tube, has the highest lift of all item sets. I can also sort by lift and inspect this head. I see that the highest lift have these 2 rules, if touring tire then touring tire tube, and if touring tire tube then touring tire. Everything we already calculated in Transact SQL. But now I will add some value in R. So I will load the library aRulesWiz, which overloads the plotting function. And I will plot graph of most important association rules. Let me enlarge this graph. And here I can see these rules nicely represented graphically. So I see Sport 100 is extremely popular product. It goes well with every other product. Size of this bubble is defined by the support. We have very big support for combination water bottle, mountain bottle cage, and the color is based on lift, darker color, higher lift. So we see here at the bottom right we have this combination touring tire tube, touring tire, which has extremely high lift, more than 12. But we can also see that this combination is not associated with anything else. Typically people, when buy one item from this pair, buy only the second item from this pair and nothing else. Also in this graph we can see some other important products, not based only on these measures, support, lift, confidence. For example, here I see an important product, Mountain 200. It's kind of transitional product. From Sport 100 I can get to Mountain Bottle Cage and Fender Set Mountain. So also these transitional products are very important. They are kind of associating item sets that are without Mountain 200 more or less independent. So another value of this graph is to find these transitive products. Also, let me use function a priori to get more detailed results. For example, which products led to Sport 100. So I will have on right hand side Sport 100, and let's see which of these products are the most important for Sport 100. So road tire tube has quite high support and really high confidence for leading to Sport 100. also positive lift. Mounting 200 can also lead to Sport 100, but lift is lower than 1, so maybe after all this is not so good association. Let's see the opposite, which products were purchased after Sport 100. So now Sport 100 is on left hand side, and I see again Sport 100 is many times on the left side, when on the right side is road tire tube, 517 cases with lift greater than 1. Sport 100 and then water bottle, we have quite high support, quite high count, but lift is negative. We already know this because Sport 100 is typically a product that finishes the shopping sequence. Let me now switch to Azure Machine Learning. Here I have an experiment called Association Rules. I already imported my data frame that I exported in a comma-separated values file in R. Let's visualize this data frame, and of course you already know it. This is a simple data frame with just two columns, order number and model. Again, we can see this first order SO61313 with model cycling cap, road 350W and Sport 100. Now there is no association rules module in this machine learning section. We have models for anomaly detection, we have models for classification, models for clustering, and models for regression. So how did I get association rules in Azure Machine Learning? Well, through R language modules, execute R script. I'm feeding the script with this data frame I imported, and I'm calling library A rules, define transactions, and define association rules, show rules by confidence, and then also load library A rules with and plot the association rules. So I basically copied and pasted the code from R. And let's visualize the results. We can see the results. So we have the most important rules: road bottle cage, then water bottle. We have support, we have confidence, and we have lift. And again, remember the second rule, touring tire, then touring tire tube, has the highest lift, more than 12. And we have also a nice graph for first or the most important 24 rules. We see Sport 100 is in the center. We have big support for combination mountain bottle cage, water bottle. And we can also see this transitional product mounting 200. Basically nothing new. With help of R, I could get association rules also in Azure Machine Learning. Of course, the next question after I have shown association rules in R is, do we have also association rules implemented in Python? And the answer is yes. Unfortunately, I don't like the implementation. Maybe there is some other better implementation, but I definitely don't like this library called a priori. So let's import this library a priori. And please note what am I doing here. I am creating just a sample of transactions manually. I simply copied this from SQL Server. So I'm creating a set of 10 transactions with 2 different products or models in each transaction. And I will use the a priori function from a priori library and create rules as a list, and I search for rules with minimal support 0.1 and minimal confidence 1. Now I use for loop for each loop to extract the rules and extract support, confidence, lift, and print all this information. So let's see the rules. Here are my rules. For example, here we have rule left hand side short sleeve classic jersey, right hand side cycling cap, road tire tube, sport 100, support 0.1, confidence 1, lift 10. Of course, these results do not make a lot of sense because I have 10 transactions only. Why did I not like this algorithm, this implementation in Python, and why didn't I feed it with a lot of orders and line items? The problem is in performance. Unlike R, Python doesn't have matrix operations built in the core engine. That's why I needed to use for each loop. And this is slow. You get matrix operations, efficient matrix operations with library NumPy, and then with library pandas, which is built on NumPy, you get the data frame object. Practically every other implementation of every other algorithm in Python is using data frames, pandas data frames, and implementations are fast, but not for association rules. Let me show you what I mean. So now I'm importing NumPy, and I will create a function that will use for each loop to compute reciprocal values. And now I will create 1 million random integers, and I will also measure time needed for calculating reciprocal values. So let's start the timer, calculate the reciprocal values with my functions with for each loop. For 1 million reciprocal values, my function needed, let's wait a bit, 7.8 seconds. So nearly 8 seconds. Now, since I already loaded the NumPy library, my divide operator is already overloaded, so it works with matrices and vectors. I have vector of 1 million values. So let's just use now the divide operator. Without NumPy, I will get an error in this code because divide by default doesn't work on vectors and matrices. So let's calculate this with vectorized operations, and I needed 0.25 seconds, so nearly 40 times faster. Basically, the a priori library is more or less useless in Python. Maybe there is some other library with better implementation, but I didn't bother to research since I have many other very good and fast options. The next possibility is Power BI. Of course, those who already know a little bit about Power BI, you know that there is no association rules visualization out of the box. But we can get additional visuals from Microsoft App Source. Here I already searched for visuals that have ASOC in their names. So here is a visual association rules. Let's briefly look the documentation, and let's go to the end and see that this visual is actually using R, and here are the packages that needed to be installed and versions of R that you can use with this visual. So again, we are at R. But once you have this visual, you can show association rules in your Power BI. So let me switch for a second to Power Query and show you the source query I used for this visual. Of course, I connected to AdventureWorks ZW 2017 database, and I simply created all possible pairs. So I used the query with cross apply that joins over order number where model from the left is greater than model from the right. This is my query, so I get all possible pairs. And then I can use this association rules custom visual. To show these rules, Like here in tabular format, this is first possibility. So we have support, confidence, we have lift, and we have count. And then we can also use some other visualizations. For example, we can also use graph visualization. And this is pretty powerful visualization that draws circles size based on support and color based on lift. Maybe you noticed that the evaluations for this visualization were not that high. It is somehow useful, but it is very, very primitive. Could be done in a better way. Did I exhaust all options? Well, of course, there are more tools and languages and environments where you can implement the association rules algorithm. But I didn't exhaust all possibilities even with Microsoft set of tools and languages. So what I'm opening now is Visual Studio, and I have analysis services, multidimensional and data mining project there. I know that this data mining is deprecated and will be probably removed from the next version of SQL Server, and I am sorry for this because this data mining was still somehow useful. It is very simple to use. You define data source, which is basically connection string to MySQL Server. Data source view is simply metadata transferred to analysis services. So I have this VASOC seek orders and VASOC seek line items view in my data source. And then I can define mining models. Mining structure, multiple models can share the same structure. So I have VASOC seek orders and line items are here as a nested table. Analysis services data mining supports nested tables. And here is where I define mining models. So I'm using association rules algorithm. You can see that there are only a few algorithms supported with SQL 2019, probably nothing with 2022. But the good thing is that analysis services implementation has really great viewers. Before I go to viewer, let me just show you also algorithm parameters. So I'm searching for rules with minimal support 0.01 and minimal confidence called probability in analysis services 0.1. So let's go to mining model viewer and see the association rules. First, I can see the rules. So rules like Turing 1000 and water bottle, then road bottle cage. And then we have probability or confidence and importance or lift for this rule. And I can make this short and show only attribute names. So these are these rules. I can also check item sets. And let's say that I'm searching for item sets with minimal size 2 and I'm showing attribute name only as well. And I can see that I have the most frequent item set with size 2 is mountain bottle cage water bottle, what we already know. And finally, what I have here is dependency network, and this viewer is really great. Remember, I have something similar in R, just here might be even nicer. So let me show the attribute name only. This one is even interactive. So I click, for example, mountain 200, and I see all possible connections. So selected node predicts both way is joined with patch kit, sport 100, water bottle. I can see that this is really an important transitional product. I understand that this data mining will be removed in next version, but I hope that at least these great interactive visualizations will be preserved and appear in some other product, reincarnate maybe in Power BI. Altogether, we have come to the end. So we need to give a special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks community initiatives, including Data Platform Summit. Thank you for attending this. Please note 3 ways how to win prizes. Post your selfie with hashtag DPS 2022. Give session and conference feedback. Please give us the feedback. And visit our sponsors and exhibitors that enabled this conference. Follow us also on Twitter. Thank you very much also in my name for attending my session. Enjoy the rest of the summit. And please note that we still have a couple of minutes for questions. Besides recording the session, I am also here and prepared for your questions. Thank you and bye.